All right, number 3. A baseball is thrown at an angle of 25 degrees relative to the ground at a speed of 23 meters per second. If the ball is caught 42 meters from the thrower, how long was it in the air? All right, so we got how long, so it's going to be a delta t, was it in the air? How high above the thrower did the ball travel? So I got, again, 2 parts of this bad boy. So the first thing I want, actually, I haven't written down what I know. Space. Delta x was 42 meters. I have an angle, 25 degrees. I have an initial velocity. And everything. Yep, I think so. Alrighty. Now, the first thing I'm asked to do is how long was the ball in the air? Now, it's hard to do that with the y component at the moment, but it's not hard to do that with the x component. Remember, delta x is equal to initial velocity times delta t plus 1/2 a delta t squared. But again, if we're just looking at the x component, this acceleration is 0. So I can rearrange this to actually completely get rid of this entire part of the equation. Additionally, I'm just looking for the time spent in the air in the x direction, right? And so this initial velocity is not only the x component, but it's the x and y components, right, synthesized together. So I want to make this so I'm only talking about the x component. That's going to be vi. That's going to be cosine theta delta t. And so I have this original kinematic applied to my scenario based on the question. But here I'm supposed to be solving for delta t. So I'll rearrange this to solve for delta t. I'll just use simple algebra. And I'll have delta x over vi cosine theta. Now I have all of these things. I have 42.0 meters. I have my initial velocity of, 23? And then I have cosine of 25 degrees. My calculator tells me that that is 2 seconds. So I now have the understanding that this ball was in the air for 2 seconds, right? For 2 seconds. All right. What am I looking for? Okay. How high above the thrower did the ball travel? All right, so I'm actually going to use a different kinematic here. And I'm going to rearrange it just for the y component. Okay. Velocity in the y component, that is final, squared, is equal to velocity, the y component, initial, squared, plus 2 acceleration in the y direction. We have displacement. Now, normally we'd be good here, but if I'm looking for how high above the thrower did the ball travel, I know that I'm going for max, y max. Now, it's important to realize that we're going for y max because at max height, the final velocity in the y component, in the y direction, is 0. So this is equal to 0. So this part of the equation is equal to 0. Now, I'm trying to solve for how high above the thrower did the ball travel. So I'm trying to solve for this y max here. So what I'm going to do is I'm going to subtract this from both sides. And then I'm going to divide both sides by 2a. So when I rearrange this to solve for y max, which is what the question is asking for, I'm going to have a negative vyi squared over 2a. Now, I need the y component of the velocity, but I only have an initial velocity. So I'm going to take this initial y velocity and actually substitute it out for vi squared sine theta squared. And yes, you do have to square both things individually, right? It's not just vi sine theta squared, it's vi squared times sine theta squared, right? That square distributes. Again, this is over 2a. So this ends up being, let's see, what are my values? 23 meters per second. I'm going to square that. And then sine, 25 degrees. I'm going to square that. And 2a. Now my calculator tells me that is 4.8 meters.